Okay, in today's lecture, we are going to talk about handout 11, the inference for means of two groups. Now recall, we have talked about the confidence interval for one population mean in handout 9, and we then talked about the hypothesis test for one population mean in handout 10. So here are some reviews. If you try to estimate the mean of a single population, the interval estimate will have a formula like this when you don't know the population standard deviation. So you are going to use this formula to estimate the confidence interval for the mean of one single population. In handout 10, we then talked about if you want to do a hypothesis test, try to compare the mean of a single population to some established value. When you don't know the population standard deviation, this is your test statistic. So for the confidence interval and the hypothesis test we have talked about, we focus on one single population, which means we are just collecting sample from one population. We just have one single sample. Now, what if we want to compare two populations? So if we have more than two groups, we will use a technique called analysis of variance, in short, ANOVA, to analyze the data. And if you are going to take more stats class later on, you will see ANOVA. In this handout, we are going to focus on how we could do the inferences for two groups from two populations. So we have talked about how to do inference for one population. Now we are going to talk about how to do inference for two populations. For more than two populations, you are going to use ANOVA, which you will learn later in other stats class. Now, for two populations, the first thing we want to do is to decide what kind of data you are having. So there are two kinds of data. One is paired data. For example, it's a data from a matched pairs design. The other one is independent groups. That is your sample from, for example, completely randomized design. So when you got a question, the first thing you need to do is to distinguish whether it's a paired data or independent data. Now let me review a little bit. You guys still remember what is a matched pairs design? Now, we talked about that in our topic 3, design of experiment. That's at the beginning of this semester, if you guys still remember it. So it's in this note on January 22nd. So a matched pair design is each unit receives two treatment. This unit could be a single subject or two subjects. So it could be one single subject receive two different treatment. Please be careful here. I'm saying you have one single subject. So then each subject could serve as their own control. Or you could have two subjects that have been matched together. You are considering those two subjects are like twins or something, so that one received the treatment and the other received the control. You can compare it. So this is paired. This is matched pair designs. Example that we have seen here, if you are a tire manufacturer and you developed a new formulation of making tires, and you would like to see the performance of the old formulation versus the new formulation. Now you realize that there are different types of vehicles, for example, sedan, SUV, and minivan, and you try to compare those two different formulations, right? New and old. So you are going to obtain 10 cars of each type of vehicle and randomly assign 2 tires on each car to be made with the new formulation and the old formulation. So the key point here is for each car, the same subject is going to be on the new formulation and the old formulation, so it's the same subject receiving 2 different treatment. So this is matched paired design. The data you got from matched paired design is paired data. You can see that one of the most obvious feature you can notice is for pair data, the 2 groups are going to have the same sample size, right? The group 1, group 2, they are going to have the same sample size because you are doing treatments on same patient. So each patient or each subject is receiving both the old treatment and the new treatment. So the 2 groups from pair data are going to have the same sample size. So that's the first type. The second type is independent groups. Independent groups are data, for example, from completely randomized design. Again, if we go back to this note, on January the 22nd, a completely randomized design is for T treatments. You have replicated NT times each, and you use a random number generator to assign the treatment to the EUs. And the example we proposed here for the completely randomized design is, you want to determine the effect of 3 different diets on weight gains in humans. Now, how would you like to design your experiment using this completely randomized design? So you use a random number generator, and you generate number 1, number 2, number 3 for each EUs, and each EU will receive 1 treatment. So if you're doing completely randomized design on 2 different groups, then you see they are from 2 different groups, so they are independent groups. Again, one feature that you could see is most of the time the sample size may not be the same. I'm not saying that the paired data have the same sample size for 2 groups, that's for sure. I'm not saying independent data could not have the same sample size for the 2 groups. It also could happen that you have the same sample size for independent data, but many times it's not the same. So this is paired data versus independent data. Again, the first thing you do is to identify whether the data you got from the question is a pair data or independent data. Now let's take a look at examples to identify in which case it's a pair data and in which case it's independent data. This is the discussion board 5 that you need to do, which I posted on Moodle. So I'm going to stop this video here, and we are going to talk about the answer in the next video. You could take this time to work on this problem on your own.